All right, Advent of Code Day 7. Got my bro here. Gonna be easy work today. Hopefully we can finish this up real quick because we have somewhere to go. It's one of our friends' birthday party, so let's get it. Day 7. Like with these, there's just a ton of text, but you already seen questions like this. You just have to narrow it down.
Mm.
So we're on day 7. For context, already passed like the first 6, but it gets harder each time. So day 7 might be really difficult. Hopefully not. You know how to say this?
Nah, cephalopods.
Yeah, yeah, yeah. I
Okay.
had to look that up too. All right, you thank the cephalopods for the help and exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Upon the large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly, you find yourself in an unfamiliar room. The room has no doors, and only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Seems like not useful content
Yeah.
yet. Since this is a teleporter lab, there's a lot of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays error code 0HNO, which apparently means that there's an issue with one of the things. I don't know what that says. You quickly locate a diagram of this thing. Beam enters the manifold at the location marked. So this is the entrance, and it always goes downwards. And then, like, it's essentially a laser. It looks like it's a laser that goes downwards. If it hits a splitter, it splits. It's hits. If it hits a splitter, it splits. The beam is stopped. Instead, a new beam continues from the immediate left and the immediate right of the splitter. Okay, so it looks like this is like a enters. It hits this thing. It splits
Yeah.
into two. Every time it hits one of these things, it just splits into two
I see.
until it splits completely. So we just need to. We can probably
Count the
just
total.
simulate that. Yeah, count the total and just simulate it. What do you think?
Yeah. Simulate it. Some type of.
Like a graph.
Yeah, pretty much.
Okay, yeah, it says how many times will the beam split?
Like a BFS kind of
Yeah,
thing.
yeah, seems like it.
Iterative, maybe.
Ooh, oh crap! What the? Yeah, so the beam hits here, and then it just probably just keeps
Keep splitting.
splitting.
Yeah.
But we just need to simulate the beams.
Yeah, yeah, yeah.
And like every time it splits, like increment some counter.
Yeah. And then throw it into like some different function that just does it again.
Yeah.
And then
God
we
damn.
can bring it back all together.
Yes, sir. Okay, let's implement that real quick. Still got it. Yeah, this
Still
guy
got
still
it.
got it.
Holy. Little Rusty. Little
Still
Rusty.
got it. All right. New file. Bro, we're gonna get cooked on part 2. Put a little test.
Oh, that's only one part?
Yeah, but hopefully you can finish it quick. Now we'll come back to it. Part. Okay, this is the input. We'll just copy and paste some input from. We'll just copy and paste the way we read the input from a different day.
Nice.
So I was reading the input. Part 1. Just print out. Just make sure it's working correctly. Okay, we're reading it. And then we just need to start at the S and just start like simulating it. So, okay, let's think this through a little bit. These are these are fun ones for just coding, nothing like
Yeah.
crazy. So we should like start like a queue because you said BFS, right? We'll push
Yeah.
this guy in the queue,
Yeah.
and then it'll just, or we can even make it simpler where we start here, and then we could just scan like from left to right, right? And if we see one at the top, we just go, we just add that, right? And then we could scan from this side.
Well, why do you have to scan? We only have to make
Yeah,
one beam.
you're right.
So we just go like
Yeah,
n
yeah.
minus one or whatever. I think.
Okay. Yeah, so let's just push this guy into the
Or I
queue.
guess they don't get a grid. We just get like or
We'll turn it
we,
into a grid.
yeah, we'll turn it into a grid. Yeah, we just have to n minus one on like the y-axis.
Okay, and then in the queue we'll just store, and then like when we look at neighbors, we only look at like down.
Yeah.
All right. I wonder how it works. All right. I
So we
think
add each beam as like a queue item and just keep n minusing one until
yeah, I get from collections for DQ. All right. So let's turn this thing into a matrix quick. For we're reading each line. Matrix dot temp. For element in the line, just do a little comprehension there.
nice.
You gotta just make sure it's working for before we get too far. Okay, we got the grid.
Beautiful.
Now we just need to push the S into the Q and then just BFS from there.
Yeah.
All right, so what are we gonna do? We're gonna
Iterate first, right?
yeah. Well, we need to find the S. We
Yeah,
need to
iterate
throw
first
that
to
right.
find the S, yeah.
Be like, how are we gonna do this? Well, we can just take the first call. We know it's gonna be at the top.
Or you
Right.
could a verbose way you could do it is just like literally just do a for loop until you find the S and
Yeah,
then you start the queue after that.
that's true. We can go like this.
That'd be a lot of code, I guess. Probably a
Column.
cleaner way.
Column start equals like, where is it? Shit. Oh no, somebody else. Okay, we gotta go fast. Okay, matrix. So we're gonna grab the 0th column, and if we just find the S.
Yeah, is it guaranteed that's gonna be at the top of the row?
Yeah, yeah. That's a good question if you're actually in an interview. But like in the input, dude, just give us this one input.
Oh, okay.
This list object has no attribute find. Oh, okay. Find element.
Python.
Find index in Python. We can do this little searches. It's not cheating. Dot index of 30. So it tells us 0, 1,
Okay.
2, 3, 4, 5, 6. So, and we know that the row start is always gonna be on row 0, right?
Mhm.
So now we just our queue. We just started with the row start and the column start. And now we just perform splits. Now we just perform this breadth first search while the length. So while the length is the queue, we're gonna pop out an element. We're gonna get the row and column queue dot pop left.
Yes, sir.
And then we're gonna look under it.
Yeah.
Yeah. So we're gonna look one under it, so we just add to the row.
Yeah.
So we say candidate row, or we'll say next row,
What?
next column, or what are you saying?
But yeah, I guess I don't know. Depends how you do it. I was gonna do like while row plus one or whatever, but same thing.
Okay. I'll just do,
Yeah, just do your way.
we'll just do like next row. So we just look at the next row and next column.
Yeah.
If, like, we need to check if it's balanced too. Next row is less than,
But also like the next row can also like oh actually yeah, you're right. Yeah, you got it.
because if we're like checking, it might break.
But like you have to make that a loop as well, right?
Oh wait, let's see here. Which one? Oh, actually, we don't.
You might already be doing it, but the second one has to be a loop too, right?
Oh, wait. Where'd I go?
Oh,
Which one?
like you have to keep going -1 until you find the split. It's like next row, next
Oh yeah,
column has
yeah.
to be another loop.
You're right. Wait. But I think what I'm gonna do is like I'll do it in the while loop. Like if it's a split,
Oh,
I'll
okay,
increment.
okay.
But if it's not, I'll just add it
Yeah,
into
yeah. Everyone has like their own little way of doing it. BFS. So many.
yeah. So if the next row is less than equal to the length of the matrix, then it's in bounds.
Yeah.
Then if it's greater than or equal to, we continue.
Yeah.
Because we don't want them to break.
Might as well just do that with the column too, right?
Yeah. Or I think only if we're gonna when we do the split.
Yeah.
Because we only look to the left if we're gonna
That's
split.
true.
So like if
Do the split case now, right?
yeah, like we'll do if
Next row.
it's just a dot, then we can just continue, right? If
Yeah, if it's a dot, we can continue.
if matrix next row next column is equal to if it's just a dot, then we just need to what I'm gonna do is I'm actually gonna like actually just write into these so for debugging purposes like these.
Nice.
So if the matrix is a dot, then we just need to add it to the queue. Next row, next column. Like I mean, it could only be the other thing is a split. I'll split plus equals 1. Then what we'll do is queue
Yeah.
dot append.
Well, yeah. We want to check the column case as well first before the.
Or I guess we can add the column case here if it's in bounds. Because if we add it to the queue, we don't care. If later it comes in. Oh no, it's considering this.
Wait, you don't need the column case there yet. Yeah, we can skip the column case for now. We'll keep that line, right?
Which line? Yeah.
The drawing? Yeah, nice.
So like we'll do next column if this is greater than the length here. Or next call less than 0. We continue. But q dot append, we'll say next row. And then like
Nice, yeah.
next column
+1.
-1.
We'll do both sides, right?
Yeah. We'll do like I'll go
-1
left
first,
first
yeah,
and then
yeah.
like the right.
Nice. And then what? You're gonna do the count at the end?
Yeah. Probably just like print out the splits at the end.
Yeah. Or you could
Let's
just
see how
be
it
like,
looks. Ooh.
or honestly, wait, you
Okay.
could print out the splits, yeah.
39. It's already off. Shoot. Okay, we'll debug that for line and see this quick. Let's just see how our thing looks. What the? Oh, start so late. What? Oh wait.
No, yeah, you're printing the second one.
I feel like
Oh,
we're doing it right. What is it
Yeah,
saying?
it's because we're counting, like we're counting split one, and I think we're like still counting like this split here, right?
Oh, we kept it going.
Or I guess that comes from here. I guess like it actually is kind of complicated because if
Hold
these two splits join after, then you can only count one split, right? Like if you have two sides that are like kind of close beside each other,
on. Oh,
and it comes
okay.
back to the same side, you have to subtract one.
Yeah, I guess like, well, this split, but we can't add this element twice in there.
Yeah, yeah,
Like
yeah, exactly.
we have to maintain a scenery.
Exactly, yeah.
Yo, we're unstoppable. In a sec. Um, like when we visit a row, add. I don't know. I don't know. We'll just add to here as we. Scene dot add. I'll just add to the set whenever like I actually put it into the queue.
Yeah. Mm,
What?
we didn't do any set check.
Oh yeah, you're right. You're right. If
If roll call would seem.
come on, please. Woo! Jane Street, hire us. This is all right. That's good. We're looking real good today on the first collab.
That
Let's-
is
let's-
splendid. Is that it? Is that all they make you do?
I mean, that's hard, bro.
Yeah, but like they don't throw any like hard test cases at you or nothing?
Oh no, just one test case, but
Just
like
one?
no, it could get harder.
Not like Lico where they throw like 1,000 edge cases.
Woo! Gold star, one gold star. All right. What is gonna sing? Okay, they still didn't hit us up. Part two, real quick. Feeling good. With your analysis of the manifold complete, wait. Let's spin up a part two. I'll drop this right away while it's still hot. 'Cause people are just trying to do it
100%.
right now. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you are surprised to discover that it isn't a classical manifold. It's a quantum thing. With a quantum thing, only a single is sent through the manifold. What? The particle takes both the left and right path of each splitter encountered. Since this is impossible, the manual recommends the world's interpretation of quantum splitting. Each time a particle reaches a splitter, it actually time itself which split it. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and in the other timeline, it went right.
Oh.
To fix the manifold, you really need to know what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold.
Yeah.
There's a timeline where it went left,
I think
always.
it's just like a DFS now.
Yeah, it could be like a backtracking or even like
Or-
a straight up like DP.
Oh,
Because
yeah.
like you'll be storing sub problems. Like if you already stored this way, you already know how many times it split in order to get here. Then you could just you don't have to go back up and calculate.
Wait, so what's the result of this? 40 times?
Like we can
Wait,
I
why
think-
why is it 40 times here?
like I think we just draw all the possible combinations that it can get to. I think it's basically
Oh,
asking
okay,
what are
okay,
the
okay,
number
okay.
possible. Like pretend it goes left, right?
Yeah.
But then also it could go right and then left.
Yeah.
So we just
And
need to like backtrack or just come up with all the possible combinations there.
Yeah.
She, alright. I think so. That's what it's saying, right?
Yeah.
Good. Water. Want to write it up?
No, not that. I'm still a little rusty. Let me get some water too.
Hold on, let's pause this real quick. So yeah, I think at each one we have to make a decision to go left or go right. It's kind of like a backtracking. You go left in one world, and then when you get to the end, then you'll just backtrack.
Yeah.
You'll backtrack until you'll just like, yeah, you'll just split into the different worlds and try to and like add them up.
Yeah.
So
Makes
we
sense.
can reuse a lot of the same code. So we have like we'll start at the row and column, and we're gonna need to add up some of this. But let's just say that this is the column start. Okay, we're just gonna write up a backtracking algorithm real quick. So backtracking is like, we'll just do like a boilerplate backtracking algorithm you take in the matrix. Take in the row, the column, right? So this is us looking at a specific cell. It's just like, we'll simulate it on a small example and then build up from there. We'll do like a small example. We'll call backtracking on like this row and column. And what we're gonna do is if matrix, we could use a lot of the same commands. Row. First we'll do the edge checks to just make sure that it's not. Oh, this might get complicated. Nah. We'll do the edge cases just so we're not going out of bounds on any of the cells. So we do if the row is greater than, then we return. If the column is greater than or column is less than, then we return.
Mm-hmm.
Otherwise, what we're gonna do is if it's just if what are we gonna do? Okay, if
I have no backtracking so long.
so we're at S, we pass S, and then what we're gonna do is we're gonna mark it, but then we're gonna call it, or we're gonna look one row below it. Like we're gonna look at the row below it, and if the row, okay, we're gonna have to copy some of this code as well, because we're gonna need to know the next row to analyze what we're gonna do in this operation. So we're gonna look at the row behind it. And we're gonna say, we're gonna have this like this. If the next row is equal to a dot, then all we'll do is we'll just return backtrack. We'll pass in the matrix. Then we'll pass in the next row and the next column, right? If it's actually a split, but we'll add all these checks real quick. If like this one right there, yeah, we'll be done this real quick actually. Return 0. So if it's equal to dot, Yeah, if it's equal to dot, we just call backtrack on that because
Mhm.
we're just running it on the next row. Otherwise, we're gonna return like backtrack on
Yeah.
like if we split it.
Yeah.
Next row, column -1. So these are the two possible ways. Then we just
Yeah.
could call print backtrack on the matrix start or row start. Holy, done my timeout. Let's see.
On that little input?
Oh no,
No.
it was a large input.
Oh, which one did you feed it? The huge
The
one? Oh,
huge
okay,
one.
okay.
Oh yeah, we might have to do backtracking. Let's just see if this works quick. What?
Oh, you didn't? I don't think you incremented like an actual count to your
Oh, if it
backtrack function.
splits, yeah, yeah. Wait, if it.
Like
Oh,
you have to add like the combination.
yeah, because we're gonna split here.
Yeah.
39.
Yeah, then we'd have to add the scene.
Do we
Right.
need to
Oh no
add
no
the
actually no
scene?
no no my
Because
bad, my bad.
if it went the other way, backtrack column -1. What's the next row? They there?
Soon. Yeah.
Okay, okay,
I just
okay.
said we're coming soon. He said he's walking.
If the next column is greater than, why are we only hit 40
Well, 39 is what we what we had last time, right?
for the first one? No, it's like 21. The first question is 21.
Yeah, we had 39 before we were in a set. Wait, let's think about it.
If the next row.
No, that is true though.
Wait.
Because we're adding like the are we adding points where like we have already seen? Is that not a thing? Like if we have two diversion points and it reaches the same path.
But like it's a different path if it splits somewhere
Oh yeah,
different
yeah,
up
yeah, I
there.
guess so.
If it's every time it hits something, we have to add one or it's split once.
Oh yeah, 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 yeah,
Or no,
yeah.
we have to wait. We just need in total the particle ends up 40 different timelines.
Yeah, yeah.
So I think when we just get to the bottom, we just need to add one. If the row is equal to the length of the matrix, there you go.
Ooh.
Now we just need to cache some stuff. So large. We'll let it run. Hopefully it just goes by itself.
Do they have timers on their tests?
Yeah, but nah, but it just crashed. It some like I already tried this last year and some just don't run. Okay, where do we cache? I guess we could just cache on the row and column. Yeah, yeah. Cache, cache. Matrix or cache equals if cache that. That. Go with this. Cache. that. So if wait, cash equals. Oh, we had turned this into a tuple.
Yeah.
This will be proper cash.
Okay.
Where?
Well, like you're reading the matrix as a tuple. The
Or
if statement.
oh yeah, you're right. Cash.
The cache needs to be a tuple. The matrix needs to stay
Yeah,
the same.
you're right. So if this is in cash,
Yeah, you just gotta add an extra bracket on line 45
where?
for your matrix indexing. Line 45, 46, 46. Yeah.
Where?
Oh wait, sorry, that's good. Is it?
Dude, that's gonna run way faster.
No, yeah, you're not slicing the matrix. Correct.
Where is it?
On 46.
Oh,
Yeah,
you're
you
right.
close
You're
it.
right. You need to go like this.
Yeah.
What? Oh,
Cash.
come on, please.
Yeah,
We're gonna have a good night if this works.
100% agree.
I think we would have won the contest.
Is that right?
Some of these guys are so fast. Crazy. Woo! Whoa! That was a legendary performance.
I like that.
Dude, that was crazy. What are your thoughts? That was wild. And just
It's been
one
a
goal
while,
like
but
that.
you're good.
That was crazy.
You're real good now.
A little bit of DP. All right, catch y'all on day 8.
Yes, sir.
Thanks for tuning in. First
Thanks for having
collab
me,
is
JP.
legendary.
Thanks for having me.